Following on from the previous video, we got to this stage here. Remember that g of x here represents this area here, and x is this bar that can slide back and forth. Okay, so we got to this stage here. When you get to this stage here, you can interpret this as being, well, if you want to know the area, if you want to know this area here is equal to you finding the antiderivative of this and then evaluating it at x. That would be this plus a mystery number. Okay, so when you get to this stage here, you can interpret this as being, well, if you want to know this area here is equal to you finding the antiderivative of this, evaluated at x, and then plus a mystery number. Okay, so when you get to this stage here, you can interpret it as that. But this has always been our aim. Our aim has always been trying to find a way of evaluating the area from A to B. This has always been our aim. Our aim here has always been trying to find a way of evaluating the area from A to B. But then now we are at a stage where we have the ability to work out the area wherever x may be. X can slide back and forth. When we are now at this stage here where we have the ability to work out this area. Well, this area is equal to us finding the antiderivative of this and then evaluating it at x and then plus a mystery number. So if this has always been our aim, you could put up an argument and say, why not just set x to be b? Set x to be b, and then we would then be able to use this to work out the area from A to B. You could put up an argument by saying, why not just set x to be b? And then you pretty much have a way of finding out from A to B. So okay, it won't work, but let's try it. So now remember, this has always been our aim. If this has always been our aim, well, then why not just set x to be b? So let's try and do it. So let's set x to be b by using this here. Okay, so then g of x, in this case g of b, okay, equals capital F of b plus a constant. So now by you getting to this stage here, you're saying, oh, the area of this, the whole area of this is equal to this, which we can evaluate, plus some sort of mystery number. But the thing is, we don't know this mystery number. What's the point of stating the area when well, you stating the area as being this thing, which we can evaluate, plus a mystery number. We don't know this mystery number, so we've got a way of we know the area is this plus a mystery number, but we don't know this mystery number. You see, when you get to this stage here, you have the ability to do that. But if you just do that, then you're stuck with this constant. You're stuck with this mystery number. The way we get around this is by creating a point here. Let's call it Z. Okay, so we can use this to evaluate this by creating a point Z somewhere in here. Okay, let's try it. Okay, let's say Z here. Remember, hang on. Going back to here, this thing here is saying that this thing here is saying that we can work out from one point to another, wherever x may be, by just simply finding the antiderivative plus a constant. Okay, so this is from this area here is from A to x here. So if we select a point, create a point Z. Okay, so create a point Z. So now if you want to find out from A to B, if you want to find out this area from A to B, then this whole thing here, remember this is our target here, to find the area from A to B. Well, create an artificial point Z. So evaluate from Z to B, that's from Z to B, okay, so work out this whole area here, and then take away from Z to A. Okay, so then what's left would be from A to B. So basically, yeah. So from Z to B, so that's from Z to B, take away from Z to A. Okay, so this thing here is equal to this thing here. Now we can use we can now jump from here to here. Okay, because we have the ability to work out the area from one point to another. Okay, so now from Z to this point here, it would be us doing this, and then plus a mystery number. Okay, now and now looking from Z to A, we have the ability to work out the area from one point to another point. So from this point to this point here. So that would be us doing capital F of A plus that constant. You see, when you do it this way here, when you do it this way, the two C's will cancel each other out, leaving you this. Okay, so if you want to evaluate this here, create an artificial point here, and then apply what we know, and then the two C's will cancel each other out. Okay, and by the way, you don't actually have to create this artificial point. It will still work even if you select this point here to be A itself. Okay, so it will still work. So from here that will take you to here. From here that will take you to here. And then the two C's will cancel each other out, giving you this. So when you want to evaluate this, it will become this. Okay, I hope you understand.